In this section, we're going to finish up, 7.2. So let's look at page 151. Again, for those of you who weren't listening there, page 151. So let's do problem 8.82. So according to a Pew Research Center nationwide telephone survey of adults conducted March 15th to April 24th, 2011, 55%, let's circle that number, of college graduates said that their college education prepared them for a job. Suppose that the survey included 1,450 college graduates. What is the point estimate of the corresponding population proportion? Well, we know that the 55% was from the survey, so the best point estimate, remember, is p hat, which is 55%, or 0.55, since we need to change it to a proportion. Alright, now let's look at part B. Construct a 98% confidence interval for the proportion. So confidence interval for the proportion are the important words there. Of all college graduates who say that their college education prepared them for a job, what is the margin of error of this estimate? Alright, so in order to find a confidence interval for the proportion, we need to use one proportion z interval in the calculator. Now, we know our confidence level is actually 0.98 because they told us here in the problem. We don't know what x is, but we do know n was 1,450 people. Now, we have to find what x is, but remember that p hat is equal to x over n, or x is equal to np hat. So we know n is 1,450, and then we multiply times the p hat of 0.55, and we get 797.5. Now, whenever you are finding x, you need to use the normal rounding rules that all of you know already. So you would round this just like you normally would, and this means that this would be 798 people. Alright, so the x that we need is 798. So let's find the confidence interval. So I'm going to pull up the calculator on the screen right now. So I want you all to sort of follow along with these calculations right here. I actually don't know why this is going over on this side of the screen, so I'll erase page 151 so that all of you can see this. Alright, so follow along with me. Turn your calculator on. On. And I don't know why my calculator is not turning on. There we go. And then remember, you're going to press stat, then go over to test, and go down to 1 proportion z test. Hit enter. Sorry, I don't know why mine wasn't showing the interval. Let's go down to 1 proportion z interval. There it is, A. And we know that the x was 798, and the n was 1,450, and the confidence level is 0.98. And let's go and calculate this, and there is our interval. So I'm going to write that down. This is the interval for part B here. So we have 0.51995 to 0.58074. But we have to be careful about what they're asking us for. They're not asking us for the interval. They're asking us for the margin of error. Now remember that the margin of error is actually the maximum value or the high value minus the minimum value or the low value all over 2. So we have the 0.58074 minus the 0.51995 over 2. That gives us a margin of error of about 0.03, or about a 3% margin of error on the percentage of people who say that college education prepared them for a job. Alright, so I hope that you enjoyed that example. If you didn't, that's okay, because I have more. Alright, analyzing poll. So when you are analyzing polls, there are 5 considerations that you need to take into account. So one of them is that the sample should be a simple random sample and not an inappropriate sample. So that would mean something such as a voluntary response sample. So anything that's voluntary. Oh no, did I spell voluntary incorrectly? Here we go. Okay, voluntary response sample would be actually something that would be inappropriate. Here's the second consideration. The confidence level should be provided. And here is one of the most important things I'm going to say in this video, and it's that if it is not, assume it is 95%. So again, a lot of these studies that you hear on the news aren't going to tell you the confidence level at all. So assume that it's 95%. And 3, the sample size should be provided. So again, that should definitely be provided. 4, except in very rare cases, the quality of the poll will depend. So the poll results depend on the sampling method or the size of the sample, and not, and here's the key word, not on the size of the population. So those are a few of the things to sort of keep in mind. And then 5, there's a very common misconception that the poll results are unreliable if the sample size is a small percentage of the population size. So here's a common misconception. Again, it is that the poll results are unreliable if the sample size is a small percentage of the population size. Alright, again, these are all things that if you think about any survey you've heard on the news, they probably have violated at least one of these considerations, and that is why you need to sort of keep these all in mind when you do analyze a poll on your own, or just go and look at a poll that somebody else has done. Alright, now I'm going to turn my page here. So let's go and look at page, whoops. Alright, I hope that all of you are enjoying this so far, but let's look at page 152 and sample size. So here we go, sample size. So there's 2 cases here. One is when an estimate of p hat is known, and then you would use n is equal to z alpha over 2 squared times p hat times q hat over the error, that's alpha over 2, error squared. And case number 2, when an estimate of p hat is unknown. Alright, so you have 2 wonderful cases here that you will have to deal with. And it's really the same formula, but you would just assume that this p hat and q hat up here are actually just 0.5, meaning that you have a 50-50 chance over the error squared. And 0.5 times 0.5 is actually 0.25. Oh boy. Oh no! Alright, I did not mean to do that, so I guess I can't really go back and undo that. So here, I hope that you remember what case 1 was. It was p hat known. Let me just review here. I don't understand why that just went off the screen, so that hasn't really happened to me. That hasn't happened to me before. So, and then case 2 was when p hat is unknown. Alright, so hopefully you all have that down. So I said that it was z alpha over 2 squared times p hat times q hat over the error squared, and this guy right here can be replaced with a 50-50 shot if you don't know what p hat is already. And so 0.5 times 0.5 is actually 0.25 all over the error squared. So these are the 2 formulas here and here that we're going to be working with in example 42 right here. Alright, again, you didn't need to hear me tell you these formulas. They should be all on your formula sheet already. Alright, so let's go down to example 42, cell phones. As a newly hired manager of a company that provides cell phone service, you want to determine the percentage of adults in your state who live in a household with cell phones and no landline phones. And then the question is, how many adults must you survey? And the question about how many adults is how I know I need to use one of these formulas for N that I just told you about. Assume that you want to be 90% confident that the sample percentage is within 4 percentage points of the true population percentage. So this is also very important because it's telling us our confidence level and our margin of error, which is going to be 4%. Alright, part A. Assume that nothing is known, so part A, nothing is known about the percentage of adults who live in a household with cell phones and no landline phones. So remember the formula for when nothing is known. It was z alpha over 2 squared times 0.25 over the error squared. And again, if you forgot how to find the z alpha over 2, alpha is 10% or 0.10 because 100% minus 90% is your 10%, and then alpha over 2 is your 0.05, so you have a 0.05 here and a 0.05 here, and then your 90% or your 0.90 in the middle here. Alright, and then you know your margin of error is 0.04. Remember how to find the z alpha over 2, it was your inverse norm, and your area is 0.95 or 1 minus 0.05, your mean is 0, and your standard deviation is 1 for the standard normal distribution or the z distribution. So your z alpha over 2 is 1.645. So 1.645 squared times 0.25 all over the error squared, or the 0.04 or the 4 percentage points. So that is giving you 422.82. Now, when you are finding N, remember this, Austin, alright, finding N, you are always going to round up. Always. Always. When do you do this? Always. So, this will be 423 people. Keep that in mind, that when we're finding N, always round up, no matter what. Alright, let's look at part B. Assume that a recent survey suggests that about 8% of the adults live in a household with cell phones and no landline phones. Survey is based on data from the National Health Institute survey. So we know that the p hat is now 8%, or the 0.08, and the q hat is going to be 1 minus 0.08, or 0.92. So we have our formula here. I'm going to make sure that I do not erase everything like in the last time. Alright, so that n is z alpha over 2, or the 1.645 squared, and then p hat 0.08 and q hat 0.92 all over the 0.04, or the error squared. And that's giving me 124.48. Now remember, I always round up when I'm finding n. Always round up, always, always, always. So this would round to 125 people, even though it says 124.48. Alright, you always want to make sure to include that extra person so that your results of your survey are valid and you don't have to go and redo your survey again. Alright, so that is it. So these formulas aren't too bad to use. Just remember how to find the critical values and all of that, and pay attention to whether your p hat is known or unknown. I hope that all of you are very excited about this, because we are about to do my favorite page in this section, and that is page 153. So, topic 12. Finding the point estimate and E from a confidence interval. I don't know why that pop-up notification is happening here. Alright. So finding the point estimate and E from a confidence interval. So express the confidence interval 0.720 less than P less than 0.780, or P is between 0.720 and 0.780, in the form p hat plus or minus E. Remember from the other day that p hat is the maximum plus the minimum over 2. So that is going to be 0.780 plus 0.720 over 2, which is 0.750. Alright, Alyssa, I'll let you chime in on this one, alright? So, what was that, Alyssa? Do you know what it is yet? Did you say 0.030? Alright, great work. So, if I want to write this in the format of p hat plus or minus E, then I will say that this is 0.75 plus or minus 0.03. What do you think is more informative, this interval that you had at the beginning, or the interval that's written as 0.75 plus or minus 0.03? I think, honestly, this is more informative than what I started with, because I know that the margin of error is 3% without even looking at anything else and having to do these calculations myself. But that's just my opinion. Alright. And my opinion is invaluable. At least I think so. Alright. So, let's look at number 12. Express the confidence interval 0.222 plus or minus 0.044 in the form of p hat minus E less than p hat plus E. So this isn't going to be too bad to do. We have the 0.222 minus 0.044 less than p less than 0.222 plus, oh, that's not a very good 2 there. Alright, 222 plus 0.044. And then if I simplify, I get 0.178 and 0.266. Alright, so I hope that all of you enjoyed that. We have one additional example down here. When determining the sample size, we need to know p hat. If we have no prior information, what are two methods that can be used? We did one of them a little bit earlier, and that is to use p hat is 0.5, or a 50-50 shot. And the second one would just be to use the result from a prior study. And that doesn't mean to not go and do your study at all. It just means that, for example, if you're pulling people about how many people brought coolers into Comerica Park, you may want to actually use last year's numbers of people who brought coolers in as an example or a starting point for estimating the number of people for this year. Alright, so that's just a short example of something that you might actually want to do. And pretty much that is it for this section on 7.3. Again, I really hope that you enjoyed this tremendously.